Hi, and welcome back to another episode in the C# Practical Funciness series. Today's episode is part 2 and the final part of my experiment with the validated of T applicative functor. If you haven't yet watched the previous videos on the validated of T, or part 1 of this series where we focused on value objects, I recommend watching those first. You'll find all the links to the videos and the full source code in the description below. In part 1 we explored how the validated of T functor can be used when constructing domain value objects, or more accurately, how it helps us to create objects that must not be instantiated in an invalid state. We also looked at how this can be extended to multi-tenant applications using what I described as a semi-dynamic approach. This allowed us to build validator functions on the fly using tenant-specific configuration data, giving each tenant the ability to customize both their validation rules and the associated error messages. In this second part, we're turning our attention to a different kind of validation, objects like DTOs, which can be created in an invalid state and then later validated. So again, we'll be using the validated of T functor, but this time to validate objects such as DTOs after construction. We'll look at two main approaches, using hard-coded validators with embedded metadata and a continuation of the semi-dynamic configuration-based validator strategy for multi-tenant scenarios. Now, if you remember from part 1, I mentioned that one of my real-world multi-tenant production apps handled validation of DTOs purely using reflection and configuration data. That approach is often cited as an anti-pattern, despite the fact I've never had issues with it in practice. So just to give you the full picture and let you make up your own mind, I've also included a very basic generic validator that uses reflection and our validated of T approach. It builds validators dynamically based on configuration rules, just like the semi-dynamic approach. As a reminder, I encourage you to leave in the comments your thoughts about the approaches shown, and I would love to hear about any real-world experience that you have had in dealing with validation in a multi-tenant app for comparison. Before we dive into validating DTOs, let's take a quick look at some of the changes made since the first video. Nothing major has changed, just some reorganization to make the core validation code more reusable across different layers. In particular, I introduced a new project, validation.contracts. This project is designed to hold shared types like DTOs and their corresponding validators. It allows you to reuse the same validation logic on both the server and .NET based clients, e.g. Blazor or Maui, which is a great way to avoid duplicating rules in multiple layers of your application. The Validation Contracts project references the Validation Core project, so it can use the shared validated of T validator factories and rule composition functions. Before we jump into the actual validation of DTOs, there's one small but important change I made to the validated of T implementation. We're still using the same Applicative Functor implementation as shown in all of the other videos. However, in this part, I needed a way to add multiple validated of T results to a single list, and the only way to do that was to have an interface without the type parameter, given the validations on different primitive types. The sole purpose of the iValidated interface is to allow us to store validated of T instances in a list, and then collect and process all the failures. We'll see this in action shortly when we start pulling together failures across a DTO object graph. I also added another iValidator factory implementation called Rolling Data Only Validator Factory. This one is specifically designed for multi-tenant validation that depend on the current date. For example, validating a date of birth falls within a rolling age range, like between 18 and 122 years ago. While we're on the topic of interfaces, I also added two more, an iObject validator of T and an iTenant object validator of T. The iObject validator of T interface is for use in non-multi-tenant scenarios with the more traditional hard-coded validator setup. It simply defines a single method, validate, which takes an object of type T and returns a validated of T result. You'll see this implemented in validators like the ContactDTO validator. In contrast, the iTenant object validator of T interface is designed for the semi-dynamic multi-tenant use case. It also defines a validate method that returns a validated of T, but it requires a few more extra parameters. The object of type T to validate, a list of validation rule configs and a validation factory provider. This interface powers validators like the ContactDTO validator, which builds up validation rules based on tenant-specific config data at runtime. I made a few additions to the validator factory's static class, mainly by including some extra reusable validators. However, the most important update, especially for harmonizing validation between value objects in DTOs, is the create property validator method shown on line 65. This method now serves as a central point that connects an object's property to its corresponding validation rule configuration, allowing us to dynamically build validators using tenant-specific data. It standardizes how we build validators, whether we're working with value objects or data transfer objects. Before we look at the DTO validators, let's quickly glance at the ContactDTO itself. There's nothing particularly special here, just a few straightforward properties. One thing to point out is the use of the nullable properties, what you might call optional fields. For example, the mobile and address properties are both nullable. Although I could have wrapped these in an option monad, I decided to keep it simple and just use C#'s native nullable types for this demo. The address DTO is similarly basic, just a few standard fields for demonstration purposes. Now let's move on to the actual classes that perform validation on these DTOs. I've taken a common approach here by separating the validation logic from the models. This means that each DTO has a corresponding validator class. So for ContactDTO, we have ContactDTO validator and so on. You could of course choose to place the validate method directly on the model itself if you prefer all the code to be in a single place. The ContactDTO validator gives us full control over how we validate each property. Each validation call returns a validated of T result, which we add to a list. Once all validations are run, we check the list if any entry is invalid. The validator returns a failed validated with all the collected errors, otherwise it returns a successful result. Most of the validators used here are shared, reusable functions pulled from the validator factories class, which helps keep things dry and consistent across the application. For the address DTO validator, I chose to define all the validators directly inside the class, just to demonstrate the alternative. If these validators were reused in other places, it would of course make more sense to move them into the validator factories class as well. Next up is the ContactTenant DTO validator, which uses our semi-dynamic approach for multi-tenant scenarios. There's nothing too complex here, it simply wires everything together using the validator factory's create property validator method. For demonstration purposes, instead of creating a separate address tenant DTO validator, I included the address related validation in line in the same class. Again, each validation result is added to a list. At the end, if there's any failures, we return an invalid result containing all errors, otherwise we return a valid result. Before we run the demo, let's take a quick look at the generic validator class, the reflection-based approach I mentioned earlier. This validator uses reflection to inspect each property, find its associated rules configs, and then call the tenant validation helper build validator method to generate the necessary validation functions dynamically. This code was only provided as a basic example of how to create a reflection-based validator. The important thing to note is that the end result is the same. We get a list of validated items and we check that list to determine whether the overall object is valid or not. To wrap things up, we're going to validate a contact DTO using good data and then bad data, with all three types of validators we've discussed: the standard contact DTO validator, the multi-tenant contact tenant DTO validator, and finally the reflection-based generic validator. Since all the validation logic lives in the shared projects, it doesn't matter whether you run the validation on the server or the client. For this demo, we're running everything on the client. For the multi-tenant validators, the client will make a quick call to the server to fetch the list of rule configurations from the server-side cache. Just like the demo code in the first video, I've only overridden half of the family name rule for tenant 1 to show the flexibility of the approach. Everything else will use the fallback values. As I mentioned back in part 1, the main goal of these videos is to give you a working code base that you can download, explore and run yourself. That way you can form your own opinions about using the validated functor in a more realistic applied context. Alright, let's run it. And with that, we're done for the experiment. I hope you found something useful or interesting in this episode. Personally, I think this pattern has enough potential that I might continue refining it, maybe even work towards a lightweight, funky validator NuGet package, who knows. As always, feel free to leave feedback, good or bad, and I'll do my best to respond to any questions or thoughts you share. If you found this video or source code helpful, please consider liking and subscribing. It really helps the channel grow and encourages me to produce more content like this. For the handful of people who watch this, thanks for watching, and until next time, bye for now.